Chapter 3, Section 3.5, Translations of Functions. Let's say we have the graph of the function f of x is equal to x squared. We know this graph represents a parabola. If you plug x equal to 0, f of x will be equal to 0. If you plug x equals to 1, f of x will be 1. If you plug x equals 2, f of x will be 4. Similar on the other side, if you plug x negative 1, you will get f of x is equal to 1. If you plug x is negative 2, f of negative 2 is equal to 4. And then we're going to sketch this graph. So this is basically the graph of the parent function, the parabola. And we know that graph. Now, if you take a look at the function g of x, you will notice that in the function g of x, the x was changed by subtracting 3 units from it. So if you look at the 0 of this function, you will notice that the new 0 happens when x is equal to 3. In other words, this function shifted the parent function to the right 3 units. So the point 0 and 0 is going to become 3. If you plug 3 into the function, it's going to give you 0. If you plug 4 into the function, you're going to get an outcome of 1. If you plug 2, you get an outcome of 1. If you plug 5 into the function, you get an outcome of 4. If you plug 1, you get an outcome of 4. So this is the new function. As you see, it's just the parent function moved to the right 3 units. If you notice any of these points, just move to the right 3 units. Any of these points move to the right 3 units. And then if you look at the next function, which is h of x, you will notice that it's exactly the parent function, but in this time, the x was changed by adding 5 units to it. So if you look at the 0 of the function h of x, you will find the 0 happens when x is equal to negative 5, meaning the parent function f of x was translated or moved to the left 5 units. So if you plug negative 5 into h of x, you will get 0. If you plug negative 4 into h of x, you will get 1. If you plug negative 6 into h of x, you will get 1. If you plug 3 into h of x, you will get 4. If you plug negative 7, you will get 4 as well. And here is the new function, which is basically the parent function moving to the left 5 units. So in short, we can say when we subtract from x, the function moves to the right. Let's say if we subtract a is an integer, it's going to move to the right if a is greater than 0, and it will move to the left if a is less than 0, meaning it's negative. So if you subtract a positive number, you will get x minus a all squared. In this case, you're going to move to the right a units. But if you subtract a negative number, that will make it into a positive. That means we're going to move to the left 5 units. In this case, we move to the left 5 units. In general, you're moving a units to the left if you subtract a negative number. Okay? So this is basically the translation, the horizontal translation or the horizontal shift of functions. As long as you know the parent function, you will be able to translate easily when that happens. The next type of translation is the vertical translation or the vertical shift. Let's graph the function f of x is equal to the cube root of x. If you graph this function, you will notice that it is 0 at 0. When x is equal to 1, the function is equal to 1. When x is equal to 8, the function is equal to 2. On the other side, if x is equal to negative 1, the function is equal to negative 1. If the function is equal to 8, if x is equal to negative 8, the function will be equal to negative 2. And then if you graph this function, you'll end up with this shape. So this is basically the function f of x, which is the cube root of x. Then if we are going to translate that by adding 2 units to the function itself, Notice how the addition here happens to the entire function. It doesn't happen to x. What this means each of these important points on the graph is going to move up 2 units. So 0, 0 is going to move up to 0 and 2. 1 and 1 is going to move up 2 units. It's going to become 1 and 3. 8 and 2 is going to move up 2 units to 8 and 4. On the other side, -1 and -1 is going to move up 2 units. That will put it at 1 and 1. And then -8 and -2 will move up 2 units. It's going to become -8 and 0. So here is the graph of the translated function that was shifted up. So this graph is g of x, which is the parent function, plus 2 units. So if we add to the function itself, the function is going to move up. If we subtract from the function will move down. Let's look at the other function, h of x. If we want to graph h of x, we know that it's the parent function, but we subtracted 3. That means all of these important points on the parent function have to move down 3 units. That will move 0 and 0, 3 units down to 0 and -3. That will move 1 and 1 down 3 units to 1 and -2. And that will move 8 and 2 down to 8 and -1. On the other side, -1 and 1 is going to move down 3 units to -1 and 4, -4. -8 and -2 is going to move down 3 units to -8 and -5. And then we sketch the graph of the function. And this is h of x, which is the parent function, minus 3 units. In short, when we add to the function, the graph will move up how many units we added. When we subtract from the function will move down. The graph of the function will move down how many units we subtracted from the function itself. The next translation we're going to study is the reflection about the x-axis and the y-axis. Let's say we have the graph of the absolute value function, x minus 3. If I wanted to graph this, I'm going to look for the 0 of the function. Clearly the 0 of the function is at 3, and I know the shape of the function, so I'm just going to plot this one. I'm going to check when x is equal to 4, the value is 1. When x is equal to -2, the value is 1 as well. So here is a sketch of the parent function f of x. So this is the parent function f of x. We know the graph of the absolute value function. Then if you take a look at g of x, you will notice that all of the values of y of the function were reflected. Now they are negative. That means every outcome from the original function that used to be positive, it's going to be negative. That means the function is going to reflect about the x-axis. Now, if we reflect this function, the point 4 and 1 is going to reflect down to to 4 and -1, and the point 2 and 1 is going to reflect down to 2 and -1. And then if I sketch the graph, it's going to look something like that. So it's just reflected across the x-axis, or about the x-axis. The graph of the function x equals h of x is equal to x plus 2. I know the 0 for that function is -2. So I'm going to sketch that graph really quickly. So the 0 is -2. The function is equal to 1 when x is equal to -1. The function is equal to 1 again when x is equal to -3. And here is the sketch of that function, which is h of x. Now, h of x, the change here happened to the x value. That means each x value that I used in this function, I will be using the opposite of it in this function. If I used -1 in here, I will use +1 in there, including the 0 of the function itself. So the 0 of the function here is actually 2 when x is equal to 2. So here is the first point. Let me choose a different color. So here is the first point. That is the 0. And then when x is equal to 1, the graph of the function will be equal to 1. So that is this point reflected across the y-axis. And then the other point, which is -3, when x is equal to -3, the function is equal to 1. So that is the function, that is this point reflected across the y-axis. Now, I'm going to sketch the graph. And as you can see, this is the graph k of x, which is a reflection across the y-axis of the green graph, which is h of x. So when the change happens to x, the reflection is going to happen across the y-axis. When the sign of the function changes from positive to negative, the graph is going to reflect across the x-axis. And if the x changes sign from positive to negative or negative to positive, the graph is going to reflect across the y-axis. Hopefully that was clear reflection. Let's determine whether a function is even or odd or neither. We know that the definition of even function, if you change x to -x, then if the function is even, it's going to give you the original function or f of x. If the function was odd, it's going to give you negative the function f of x. So let's determine, for example, number 5, whether the function is even or odd. I have a very fast way to predict whether the function is even or odd, and I will show you how. So I know that each constant is even. Each term that has an even power is even. So even and even will give me even function. If I mix even and odds, I will get neither. But if I keep all of the terms even, all of the terms are odd, then my function is going to be even or odd. Here I have x to the third is odd, x to the first power is odd, so chances that this one is going to be odd. I will verify algebraically. For now, I'm just giving you an idea of how to tell without doing the math. Looking at this is odd because it's the fifth power, and I know the constant is even, so this one is going to be neither even nor odd. I have odd, even, and then odd and even. This is going to be neither even nor odd as well. Now let me verify. If I find f of -x, this becomes -x all squared plus 6, which becomes x squared plus 6, and that is exactly f of x, and that confirms it's even. For this function, I will plug x is equal to -x equals 7 times -x all cubed minus -x, and this is going to become -7x to the third power minus times minus is a plus x, which I can pull the negative out. I will end up with 7x to the third power minus x, which is exactly negative g of x, and that confirms that my function is odd. If I have h of -x, that will give me -x to the fifth power plus 1, which will become -x to the fifth power plus 1. Now, even if I pull negative out, it's not going to be equal to h of x, and it's not going to be equal to negative h of x, and that confirms it's neither even nor odd. If I plug x equals to -x into k of x, I will get -x to the third plus -x to the second minus 4 times -x plus 2. This becomes -x to the third minus x squared, positive, plus x squared, and then plus 4x, negative times negative is positive, plus 2. Even if I pull negative out, it's not going to become k of x, and it's not going to be equal to negative k of x either, and that will confirm that it's neither even nor odd.